of our project titled Monkey Detection System using ML and AI in farmer fields. Uh, in, Introducing the project, so in agriculture, animals can be a very nuisance, causing damage to the crops. Since agriculture is a very big part of our economy, national economy, so causing problems by the animals causes harm to the economy of the farmers. So to handle that problem, we are introducing this system. The problem is the farmer faces significant crop damage due to monkeys and other animals. Our topic is about monkey. So we are introducing a system that can monitor and surveillance system using ML that can identify monkeys in the fields and detect them and send notification to the farmers. So regarding that, there were different algorithms that we have to choose from, which will be better for our model. We have chosen YOLO V7 because its accuracy is very high. For real-time processing, it's very fast, and real-time, and its model size is small to medium. And we have chosen YOLO V7 because we will be using an edge compatibility, which is very high, which will help the farmers. So there's a comparison of different versions of YOLOs. We have chosen YOLO V7 because it's very cost-effective and robust performance, and the accuracy is very high in this, and real-time processing is also very fast. So what is YOLO? YOLO is a real-time detection. YOLO stands for you only look once. It is an object detection algorithm, and it has some special properties like it processes an image in single pass, predicting boundaries boxes. That means it creates a boundary boxes around that class of the image that is predicting, and it creates class probabilities. So it is worked upon the model of CNN. This is the basic architecture of CNN. Here we use convolutional layer, ReLU pooling convolutional layer again to extract the filters, and we use this process multiple times and then convert and send it to an ANN, the artificial neural network. So how is it? YOLO is a bit different from CNN. In YOLO, we use class predictors as we have discussed. Here, the different classes like PC will show the different class types. Suppose here, two types of classes, so it will be one like this. Then the BX will be the boundary boxes, the width. The BX is the center of the image, where the center of the image is located. BW and BH is the boundary boxes width. And C1 is the class, different types of classes. Here, the dog is shown as 1, and if there is no presence of another class, it will be shown as 0. So how we train the model? During training the model, we input different types of images into the system. Images including the object that needs to be detected, and also images that do not have the objects. We input them into the system, we train them. Then the model slowly learns how to detect those objects and localize them among the different inputs that we have sent into it. Then it starts, again, the convolutional layer network starts, and using the 7 vectors, it creates a volume, a cubical structure which has a third vector containing 7 classes. So this is how it looks. It will identify 2 different objects here. So what are the different scopes of improvement in this? We can improve the accuracy, faster detection, and also automated alerts. This is the proposed system. The farmlands will be monitored through cameras and other surveillance systems. It will be transmitted through an IoT network. The model will scan the data that will be fed into the model. If the monkey is detected, it will alert the system, and the active deterrents will be triggered as well. The farmers will be alerted accordingly, and deterrents will be used so that it can scare away the monkeys. So when we are training the model, this is how it looks. In YOLO, this is the different the flow, how it uses it. The object detection model first, then it uses boundary box visualization, property definition, level visualization, and the output. when we feed an image into the model like we have shown here, it predicts with an image, and how much prediction we can see here in this next image. The precision amount is 73.8. The recall is 62, and like this, it shows the boundary along with the localization of the image, the object that it wants to detect. And this is the versions or different versions of how we train. We'll live demonstration of the projects.
Sir, ইয়াৰে পিছত আমি কি প্ৰেজেন্টেশনৰ যেটো ওয়ার্কফ্লোটো আছে হেতু ডাইরেক্ট লাইভ ডেমনস্ট্রেট কৰি দেখাই দিম আৰু জাস্ট স্ক্রিনশট বিলা
লাইভ ডেমনস্ট্রেট করবা
তেতিয়া হলে স্যার আমি ইয়াৰে পৰা দেখাব লাগিব লাইক এনেকে
এনেকে দেখুৱাই দিয়া
So sir, this is our projects. Here we have created the monkey detection project. The precision of this project is 73.8% and recall is 62. We can improve the prediction using different kind of versions. We have created 2 versions for now. This one is the first version and this is the second version. We have trained this model using Coco 14. And deployments, in the deployment we can see is like this. So if we test this workflow and select the file, like this. Video to koribo parim to etu bostu koi dile hobo na.
So etu video to pari
just video tur karone local server to connect koribo lagibo, like jodi bhargobor tate connect kori tetia video to hoi jabo.
Okay.
So enake show korile hobo
sir.
Yeah.
Frame to change.
First, you take maximum time to discuss the terminologies like algorithm that you have discussed, right? And you keep only 2 to 3 minutes for this demo, right? And next thing is that suppose monkey we detected, how to scare it or how to scare the animals, right? That part also you need to take a few minutes or 1 minute to discuss.
Okay, sir. So we can use normal Python script to send the alert, which is a simple steps, but the real model is trained. We can extract the X5 file from it and deploy it, and using alerts, deterrence, we can different kinds of sounds we can use. Then using
we
Python
can use
script.
it in like for IoT purpose also, like we got the H5.
Yes. So that is very important. Means how to scare the animals without harming them, right? So we will take care of it. Suppose some they scare about tiger's voice, right? Or say scare about some different animal's voice, or like that. We can use some bomb blasting sound also, right? So this type of sounds that we can use to scare the animals, right? And this project can be implemented for bigger elements like elephants also. Elephants also destroy the crop fields. So you give examples like that.
Yes, sir. Okay, sir. So when we change the data set, it will start detecting different animals as well, sir.
Okay. And one more thing you can say that you have already presented one research paper in a standard national conference on artificial intelligence applications of one government university, and that already been published. And one more you have submitted to an international conference of artificial intelligence, right? So this thing you have to say, so that we can say that these are the impact or output of our project. And of course, there is a positive outcome, because if we can take it to the farmers, right, they will be getting benefited, right? So this is our motive and positive outcome from this project. Okay?
Yes, sir.
Okay. So that's it. I'm happy with your project group. All the best.
Thank you,
sir.
sir.
Yeah, you can leave now.
Good night, sir.